This is how bees see flowers, and why the garden you're looking at right now looks nothing like what they see. The flower in your garden may have a target painted on it that you cannot see. Not a metaphorical target, a real one. A dark, ultraviolet pattern near the center of the petals, invisible to your eyes, but visible to the bee landing on it. The bee is not seeing your garden. She is seeing another version of it, and that version may be the one the flower was actually built for. This is the part most people miss about bee vision. We look at flowers and assume their beauty is directed at us because we can see it. We see petals, color, symmetry, softness, and think the garden is showing itself clearly. But the bee on your flowers is using honeybee eyesight tuned to a different world. Ultraviolet light, blue light, green light, contrast, motion, polarization, scent, and reward. Your garden looks nothing like what you think. The flower you admire may be hiding the most important part of its signal from you, and the bee can see it from the air. If that changes how you look at the next flower in your pollinator garden, stay with me. Because once you understand how bees see flowers, the garden stops looking like decoration. It starts looking like a message system you were never the intended reader for. Most people think flower color is simple. A red rose is red, a yellow sunflower is yellow, a purple lavender spike is purple, a white daisy is white. We walk through a garden and believe we are seeing the full display, but human color vision is only one version of light. Your eyes have receptors that allow you to see roughly red, green, and blue ranges. Your brain builds a world from that. It feels complete because it is the only world you have. But the bee does not share it. A honeybee's color vision is shifted. She can see ultraviolet, she can see blue, she can see green. But she does not see red the way you do. That means the same flower can be two different objects at once. To you, it may look plain. To a bee, it may be marked. A petal that seems evenly colored to a human eye can reflect ultraviolet light in one area and absorb it in another. A center that looks only slightly darker to you can become a strong landing guide to her. A flower that appears simple in your hand can become a visible instruction from the air. This is why bee vision is not just a strange fact. It changes the meaning of the garden. The bee does not arrive at your flowers because they are beautiful in the human sense. She arrives because the flower has solved a problem. It needs to be found. It needs to be recognized. It needs to direct the bee toward pollen or nectar. And if it can guide the bee more efficiently, the flower has a better chance of being pollinated. So the flower is not only a flower, it is an advertisement. But part of the advertisement is written in ultraviolet. In the early 20th century, Carl von Frisch helped prove that bees were not colorblind machines reacting only to brightness or smell. He trained bees to associate colored cards with food rewards, then changed the positions and tested whether the bees could still choose the color. They could. Later research revealed the deeper structure. Bees have photoreceptors sensitive to ultraviolet, blue, and green wavelengths. That is the scientific foundation under the moment you see in your yard. The bee on your flower is not guessing from scent alone. She is reading light. What this means for the bee in your garden is that every bloom has a visual identity you may not be able to see. Your lavender is not just purple. Your daisies may not be simply white. Your sunflowers may not be only yellow. Some flowers carry ultraviolet nectar guides, sometimes called bullseye patterns, that point pollinators toward the center. Have you ever looked at a flower up close and noticed a darker center, faint lines, or a ring around the middle? Did you think it was just decoration? Tell me in the comments what flower in your garden you would most want to see through bee vision. Lavender, sunflower, daisy, clover, apple blossom, something else. I read every comment, and this question matters because the answer is not only about color, it is about whether your garden has been showing another world in front of you the whole time. Now imagine the bee approaching from above. She is not seeing the soft postcard version of your yard. She is moving through a fast, bright, high-contrast world. Leaves reflect green, flowers break the pattern. Some petals flash signals in ultraviolet. Edges matter. Symmetry matters. The center matters. The air moves. The sun shifts. The bee has to make a decision quickly because hovering costs energy and her adult life is short. A flower that can be identified faster has an advantage. A bee that can identify it faster has an advantage too. This is where the relationship becomes precise. The flower needs the bee to land in the right place. The bee needs the flower to be worth the flight. If the visual pattern guides her to nectar or pollen quickly, both sides gain something. The flower gets a visitor that brushes the reproductive parts. The bee gets reward with less wasted searching. That is why the hidden ultraviolet pattern is not just beautiful, it is functional. A nectar guide is not a painting for admiration. It is a landing system. It tells the bee where to go. In many bee-pollinated flowers, the outer parts of the petal reflect one pattern of light, while the center absorbs more ultraviolet. To the bee, that contrast can create a dark target. The flower becomes less like a pretty object and more like a runway with markings. The bee lands where the signal tells her to land. Then she lowers her head. Then the flower uses her body. That is the trade. The bee comes for food. The flower receives transport. Pollen sticks to the bee. Some of it may move to the next flower. The bee thinks in immediate reward: nectar, pollen, root, energy. The flower does not think at all, but evolution has shaped its signals around the eyes and behavior of pollinators. This is why how bees see flowers is not just an internet curiosity. It is part of the machinery of pollination. The color of a flower is not only what humans see in daylight, it is what a pollinator can detect, learn, remember, and use. Bee color vision makes the flower legible. Honeybee eyes turn a garden into a set of choices. Some choices are strong, some are weak, some are invisible to you and obvious to her. That should make the next bee on your flowers feel less random. She may not be wandering through color. She may be following signs. And the signs were not made for you. There is a strange humility in that. We plant gardens and believe we are arranging the visual world. We choose flowers for borders, color balance, height, mood, season, and beauty. We talk about what looks good from the window. We think the garden is ours because we made it. But the bee enters and sees a different design. A flower you placed for human beauty may be useful or not. A flower bred for large petals may have little nectar. A bloom that looks plain to you may be rich to her. A weed along the fence may be more valuable than the expensive ornamental beside the path. A white flower may not be white in bee vision. A red flower may be dull unless it reflects light in the ranges bees can detect. The garden has two audiences. You are only one of them. The bee's version of the garden is not more true than yours. It is true for her. That is the point. Every animal lives inside a sensory world built by its body. A dog smells a room you cannot smell. A bird may see details at a distance you would miss. A bat can hear a world in echoes. A bee can see ultraviolet markings on flowers that your eyes turn into blank petals. You do not see reality. You see the part of reality your body lets you see. The bee sees another part, and the flower has learned to speak there. Right now, while you are watching this, bees are reading gardens through signals their human owners cannot perceive. A honeybee may be crossing a yard toward a flower whose ultraviolet center is pulling her attention. A bumblebee may be testing a patch of blue and purple blooms, comparing color and reward. A solitary bee may be visiting a small flower most people would step past without noticing. Across pollinator gardens, parks, orchards, and wild edges, flowers are broadcasting in a visual language we barely enter. This is not happening in remote wilderness. It is happening in ordinary gardens. It may be happening outside your window. The bee lands because the flower made itself readable to the right eyes. Then the bee learns. If the flower pays, she remembers. If the patch is rich, she may return. If the route is worth it, the location may become part of a foraging pattern. In honeybees, a strong source can be carried back into the hive and advertised through dance. The signal that began as ultraviolet on a petal can become movement on wax. Think about that chain. A flower reflects light your eyes cannot see. A bee reads it. The bee finds nectar. The bee returns. The colony changes behavior. Your garden enters the life of the hive through a color you never saw. That is the hidden scale of something as small as a petal marking. The ultraviolet pattern is not just an aesthetic detail. It can be the first step in a chain that moves pollen, feeds larvae, fills honey stomachs, and shapes which flowers get visited again. And still, from your side, it just looks like a bee landed on a flower. This is why the phrase garden bees can be misleading. It makes the bees sound like background life, little visitors that add motion to the scene. But from their side, your garden is not background. It is a field of signals. It is a map of opportunities and dead ends. It is a changing surface of color, scent, temperature, and reward. The bee is not decorating your afternoon. She is interpreting your yard. Her eyes are small, compound, and built from many facets. The image she sees is not like a human photograph. It is not sharp in exactly the way yours is sharp, but it is fast, sensitive to motion, tuned to useful contrast, and paired with a nervous system that can learn which colors and patterns matter. She does not need to see your garden the way you do. She needs to see enough to survive it. That difference is important. We often measure other animals by what they lack compared with us. Bees do not see red like we do. Their visual detail is not the same as ours. Their brains are tiny. From that angle, they look limited. But limits are only half the story. The bee also sees ultraviolet. You do not. She sees a layer of flower communication that is absent from your garden unless you use special equipment. She can use that layer while flying, feeding, navigating, and making decisions that affect the hive. Her world is not smaller than yours. It is shifted. The missing color is not missing to her. It is missing to you. That is the reversal at the center of this video. The bee is not an incomplete observer of your garden. You are an incomplete observer of hers. You are walking through a place full of signals that were not designed for your eyes, and every bee that lands on a flower is proof that someone else can read them. Someone very small. Someone with weeks to live. Someone working too quickly to admire what she sees. The bee does not pause and marvel at ultraviolet beauty. She is not having an aesthetic experience in the human sense. She is solving the next task. Find the flower, judge the signal, land, feed, gather, leave, return. Repeat until her wings wear out or the season turns against her. That is what keeps the story from becoming sentimental. The beauty is ours. The urgency is hers. Every wrong landing costs energy. Every empty flower wastes part of the flight. Every useful signal matters because the bee's life is short and the colony's needs do not pause. A flower that can say, "Land here," more clearly is not being decorative. It is reducing waste. A bee that can read the signal is not being magical. She is staying alive efficiently. And yet, knowing that does not make it less beautiful. It makes it stranger. Because now the flower in your garden is not one thing. It is a human object and a bee object at the same time. It is color for you and ultraviolet contrast for her. It is decoration from the path and instruction from the air. It is part of your yard and part of the hive's economy. It belongs to more than one world. That is what I find hard to stop thinking about. The garden did not change, only your idea of seeing changed. The same flowers are still there, the same petals, the same stems, the same afternoon light. But once you know about bee vision, the surface becomes suspicious. A plain petal might not be plain. A dull center might be a target. A pattern you barely noticed might be the part the bee was aiming for all along. the ordinary garden becomes less ordinary because you realize it was never fully visible. Not to you. The bee on your flowers is seeing colors you cannot see. She is reading ultraviolet flowers, nectar guides, and contrast patterns that exist whether or not a human ever notices them. She is moving through a version of your pollinator garden that overlaps with yours but does not match it. And right now, somewhere near you, that is happening again. A bee is approaching a flower. To a human, it may be pretty. To her, it may be clear. The center may be marked. The route may be obvious. The reward may be worth it. She lands, disappears into the bloom, and for a few seconds, the invisible design of the flower has done exactly what it evolved to do. It brought the right eyes to the right place. So the next time you look at a flower, do not only ask what color it is, ask who it is colored for. Ask what part of it you are missing. Ask whether the bee on it is not just visiting your garden, but seeing the version of it that was hidden from you the entire time. If this changed how you think about bee vision, ultraviolet flowers, pollinators, or the garden outside your own window, subscribe to the channel.